Now, what else can waves do besides reflect? Refract. No, you said very back. I said refraction. Now, what is refraction? What is absorbed?
No. It's when like a prism.
Good. It's the concept behind a prism. It's the bending of a wave as it travels from one media to another. Media in the same sense that it's what's carrying the wave, right? So right now, the media carrying the light wave in here is air, right? Now, does it have to have that air to travel? No. No, as a matter of fact, the air slows it down. But it's traveling in air right now. Yes?
Does media also mean medium?
Media is the plural of media. Right? Now, why will light bend as it goes from one media to another? One medium to another. Oh, that's my bad. One medium to another. Well, it changes media. Thank you for catching that. Why?
Is it because like the medium is influencing it to move in a certain direction?
Yes, but why? Due to, what does it do as it goes from one to another? It changes. It's going to change direction because it changes.
Oh, yeah. So it changes velocity.
Alright?
Wait, so what's that
Due to a change in speed.
I know, but what is that answer?
Oh, it's going to explain why it bends as it goes from one media to another. And I'm going to illustrate that here in a second. Alright? Now, I like to use an analogy for this. Now, keep it in mind, no analogy is perfect, and we'll point out some of the flaws in the analogy, but I think it's helpful. I use the analogy of a remote-controlled car. If I'm driving a remote-controlled car around the house, and I go from one room to another, there's a chance that my remote-controlled car will do what?
Stop moving. Move by itself.
It'll what?
Slower.
It'll change speed, right? It might slow down. Give me an example of when going from one room to another, my car would slow down.
Hit a wall.
Exactly. Going from like tile to carpet. So if I'm taking my remote control car here, and I drive straight from one room to another, from tile to carpet, my car will slow down. Because it goes slower on carpet, and it goes faster on tile. Right, it has to do with friction, it has to do with the deforming of the carpet, and
We're going from carpet
the deforming of the tires.
speed up.
Who? Yes. So if I go the opposite direction, yeah, I'll speed up. Right? So far, so good?
Yes.
So if I go straight through, then I don't change directions. But what if I do this? What if I drive my car at an angle?
Still turn slightly to the right.
Why will it turn to the right?
Because the wheels on the right side are slower than the wheels on the left side.
Good. Which of these front tires is going to hit the carpet first, the left or the right? The right. And when it does, it's going to slow down before the left front tire does. which is going to cause the whole thing to turn to the right. It's refracting because it's slowing down as it goes from one medium to the other. Now notice, when I go from faster to slower, it bends toward the normal. What does normal mean by definition again?
What is expected to be?
In physics. What's normal always in physics?
Normal. Straight.
Where did you first learn normal?
Normal force.
Normal force. And normal force always acts how?
Down.
Gravity?
Again,
Yes, perpendicular to. So here's the border, right? So the normal is perpendicular to that border. And so it's also the direction that it would go if it went straight through. So do you see how it bent to where it's closer to the normal than it was? It was like this, and now it's like that. Guess what happens if we drive the other direction?
It's going to bend towards the normal. Oh, no, wait. Slower, faster.
Okay? Let's talk it through, because yes, we know that it's going to be the opposite of red, so it's going to be away from the normal, but let's walk through why that is. Which wheel hits first? Left wheel. And when the left wheel hits the tile first, is it going to speed up or slow down? Speed up, causing the whole thing to bend to the right,
Away from the normal.
which is away from the normal.
Always right.
And that didn't bend very much.
that's what the thing with how the road works, right?
Ah, good question. Your car has what's called a differential. The purpose of the differential is to change the speed at which your wheels turn independent of each other so that you don't lose control when you go off on the shoulder. Because if you didn't have your differential, when your right wheels hit the shoulder, they would do what?
It would go that way.
It would slow down, and that would cause you to fly out to the right, careening out the road. So what your differential does is, as soon as it feels you, right, hit that shoulder, what happens to the speed of your left wheels? They slow down to match the
Wait,
speed
so
of
it's
the
like an
right
automatic
wheels.
thing on your car?
Mhm.
So that you don't spin
So that you don't lose control, yeah.
Wouldn't that not change anyway?
But if you had a remote control car that doesn't have a differential, then yeah, when your right wheels hit the shoulder, boom, you go flying off the road. Okay? So, from slower to faster then, it bends, as we said, away from the normal. Now, do you have to memorize those two phrases that I just gave you in red and blue?
No, you just have to memorize one.
Right, and I don't even have to memorize either of them. I just have to picture what's happening. If I get the remote control car right, which wheel hits first, does it speed up or slow down? And then I can picture which way it's going to bend. All right? Now, most common example of this is right here.
Oh, it looks like it's crooked.
Yeah, the pencil looks like it's broken or
Would that happen if the
crooked.
glass, if the glass was rectangular or prism?
Yeah, it happens in a pool, right? And so let's talk about why it looks bent or broken. And we're going to use an example from the pool. It's my favorite example this time of year. Here's your pool. And here's you standing next to your pool. And, oh look. There's Fluffy.
Your floaty dog that has a hole in it.
No, this is
Not a real dog.
This is dog that comes on it. With bricks on it.
Fluffy has bricks on his paw. I don't know. He owes another dog money or something. He's swimming with the fishes, right? Okay? So Fluffy's down at the bottom of your pool with bricks on his paw. Now, what do you want to do? You want to save Fluffy, right? So, can you see Fluffy? Yes. Why can you see Fluffy?
The light is clear.
Good, because light from the sun is shining down, and some of that light is reflecting off of Fluffy and bouncing up towards you. Now, as that light ray goes from water to air, what's it going to do? Turn. Which way? It's going to refract. Which direction? Which one? Okay. Away. You can speed up. Let's walk through it. Which wheel hits first, left or right? Right. And as right goes from water to air, does it speed up or slow down? Speeds up. So it's going to bend left.
I'm confused. Why does it start with right?
What?
Is it traveling this way?
What now?
Would have been right.
Picture,
Where's the line?
here's the remote control car, and here's the normal.
Is it waterproof?
Yes, it's a waterproof
This is the
amphibious.
left.
Which wheel is hitting the air first?
The right one.
The right one, right? That right front hits the air first.
Fluffy is now there.
And since it travels faster in air than it does in water,
Okay.
the right wheel speeds up, and so it bends this way.
It goes faster in air than water.
Yes. Air goes faster in air than water. Right.
Wait, what's the...
Now, sound is the opposite. Sound goes faster in solids than it does liquids, and liquids than it does air. But light's the opposite. Okay? Now, you'll hear me say this more than once. Your brain is not as smart as you think it is. Actually, it's not that it's not smart, it's just that it's efficient. Your brain needs to process information quickly, and so it takes shortcuts. It doesn't take the time every time it sees something to try and trace that ray back and say, where did that light ray come from? It assumes the simplest case, which is that that light ray traveled in a straight line. So your brain sees that ray and it says what? It came from here. And so your brain thinks it sees Fluffy right here.
Is it possible to make your brain think, like, face it back?
Yes, but it's not easy to do. It takes a lot of thinking, a lot of processing, right? Even in a mirror, right? And we're going to talk about mirrors later. Even simple reflection, right? You have to think through to see where that light ray actually came from. Because your brain defaults to saying, what?
You're on the other side.
Yeah, something's over there. If you don't believe me, walk into a restaurant that has a wall that's a mirror.
You think it's the window?
You immediately think it's twice as big, right? There's more seating over there. Because your brain hasn't thought through, oh, wait a minute. No, that person is over here, therefore that light ray is bouncing off of them, bouncing off that mirror, hitting me in the eye. So your brain's constantly looking for shortcuts to speed things up. Right. Yep. Now, So now, if this is an older pool, right, with a lot of chlorine in it, you don't want to hurt your eyes, you don't have goggles, and so what do? You look at where you think you're going, and then you jump in and close your eyes. What happens to Fluffy?
He's dead. He died well.
Fluffy's
I
dead.
know, right?
Fluffy's dead. I know, I'm such a cold, heartless, cruel person. All right.
I know that. He's like underwater.
Now, once I get underwater, what if I open my eyes underwater? I say, well, no, doggone it, I love Fluffy. I'm going to let my eyes burn this chlorine for a minute. And I open my eyes. Then where does Fluffy look like Fluffy is? Yeah, right where he actually is. Because with the light just traveling through water to my eye, it doesn't bend. It's only as it changes media that it bends.
What do you mean?
Okay?
Like from a liquid to air, you close your eyes?
Before, I was in the air, but the light was coming from water to air. After I dive in, if I open my eyes, then it's only traveling through water, so it looks fine.
Say like a human was diving in the water, do we bend down perpendicular to because you're going faster?
Yeah, actually your direction of your velocity would change as the friction of the water slowed down this part of your body before that part. Yeah. Not this much though, so it wouldn't fix it to where you say so.
He jumped in the
Yeah, good
car,
thought.
dived like this. He hit and then he goes straight down. He wouldn't be the accidentally.
That's what Thomas just said. You wouldn't bend as much as the light and no. But good thought. You can dive in pretty straight.
What if you really got AIDS when you die?
No, Fluffy's dead. Get over it. All right, now.
Why are you trying to kill off Fluffy?
Oh, he's been dead. Yeah. He's been dead.
You're the one that
Yeah, the dog walked.
He kept chewing up my homework. All right, now. Okay, look up. So now do you see what's happening here? Some of the light is staying in air, right? It's just reflecting off the pencil and coming to your eye, and so it's not bending, and so that you see it like normal. But there's some of the light is bouncing off the pencil down in the water, so it goes from water to air, and so it's going to bend. And that's why when it gets to your eye thinks it sees it in a different place than it does. You got it? Incidentally, you'll hear this question later. Object. No, that's more of your brain trying to picture, process the different pictures that it's taking and put them together. Well, and why the tires on the car next to you look like they're going backwards? Because your brain can only refresh so many times, and so we're going to try.
You like special? You like, you know, it doesn't work. Like what?
Cool girl. Okay, anyway, so objects in a pool always appear to be shallower or deeper? Shallower. You ever reach to grab something either out of a bathtub or a pool, in a shallow pool?
Like when you're
Or when you're trying to... Yeah. Someone mentioned earlier, what was the book? The Hatchet, that you guys read or whatever?
Yeah, never.
You couldn't get the fish because the fish looked shallower than it actually is, right? Because of the refraction. Yes, we're talking about that. Not the same phenomenon, but similar circumstances where your brain's just processing. Yeah. So if you reach out, if you're being a real jerk, right, trying to steal from the charities at the fountain, right, trying to reach down and grab that quarter in the fountain, it looks like it's just to here, Right? You start reaching down and you end up like this.
Or that lady who's on the power like the mall.
Yeah. All right.
They never clean those pockets.
This lady who thinks there's a block, and she walks straight through the bathroom.
Now, what about this? Assume for a second that this is not round, like it's an aquarium instead. Will you see the pencil would broken like this? If this were a flat, yeah, it's hard because the curved surface of the glass is doing something else we'll talk about later. But picture your own experience. When you stand on the other side of an aquarium from somebody, do they look like they're straight across from you on the other side of your aquarium? Yeah. Well, the reason is, as it goes from light to water, it bends some. But then what happens when it goes from water back to air? It bends in the opposite direction, right? And so it ends up straightening itself out. So they end up having their level. Exactly. But the fish aren't where they look like they are, and they're not as big as they look like they are. Similarly with, but if the person's on the other side of the aquarium, if they're in air, that person jumps in the aquarium, then they got the same issue as the fish. All right. Well, yeah, they've got a little issue too. But, all right. Hey, there's a third thing that waves do. We've talked about reflection. We've talked about refraction, and there's a third that I don't want you to get mixed up with refraction, and that is diffraction. Now, again, don't get diffraction confused with refraction. They're different. Diffraction is the bending of a wave around a barrier. And so, if I step outside the door here, on the right side of the room, can you hear me?
Yeah.
Or you go left. Could you hear me? Yes. Part of the reason is some of the sound was probably reflecting off the walls, but most of it is because the sound waves can bend around barriers. Now, next time I'm going to show you a model of how that actually works with all types of waves. But right now I want to show you another illustration of it. And that is, hello! Look at my shadow. My hand shadow on the screen.
So big.
Big, but what else is it?
Dark.
No. Is it black?
No.
Is it all black? Is it really black?
No, it's like gray.
Yeah, what about the edges?
They're blurry.
The edges are blurry. Now, why on earth are the edges blurry?
Because
Some of the light is bending around my fingers before it hits the screen. Now, I get up here. What happened to the shadow?
That's blurry.
It's not as blurry. Why? Because it's less distance versus bend around, right, to the side. Now, the parts of the shadow have different terms, and I want you to know those. The dark part of the shadow, where it's completely black, where all the light is blocked, is called the umbra. U-M-B-R-A.
Dark parts around the shadow.
Dude, that's why it's called that.
That's where all the light is completely blocked. That fuzzy spot around the edges, where some of the light diffracts around, right, and make it fuzzy, is called the penumbra.
Wait, did you say diffract or refract?
Diffracts. Penumbra. P-E-N-U-M-B-R-A. Penumbra. So the umbra is the dark part of the shadow, The penumbra is that fuzzy edge that's caused by the diffraction of the light around whatever's blocking it. Closer I get, the smaller the penumbra is. Right? Farther away.
But it's also the smaller your hand gets.
That's true. But it's not just that the size of the penumbra. That's a good question. Or a good point. It's not that the size of the penumbra is just getting relatively smaller. It's actually less because there's less time for it to bend around. Right? Yep.
Is it because it's not like it's
Right. Because as the light hits my hand, it bends. Well, if there's a greater distance from where it hits the barrier to where it hits the screen in this case, there's more time for it to bend around. And again, next time I'm going to show you basically a virtual ripple tank that will show you how water waves, as an example, diffract and bend around. And we'll learn Huygens principle and some other things that will help to demonstrate what's going on. All right? Now,
Take it all off.
Wow.
The middle back one.
Totally. This one?
Yeah. It's like the most important one. The only important one.
Board?
Now I gotta take it all off.
Take it all off.
All right. We're going to hammer down one more thing real quick, and it's similar to Fluffy. I'm just in a drawing mood here. Now, let's say, listen up. Let's say I'm driving along the road in my soapbox derby car, my shade, hair following in.
The hair flying.
All right. Now, let's say it's a hot summer day. What happens? Listen. What happens to the area right down below by the pavement?
It heats up and you get the waves.
Really hot, right? What's true about the air a little bit further away from the pavement? It's a little bit cooler, right? Now, not a lot, but just a little bit. Because of the radiation off of the pavement, it's really, really hot at the surface of the pavement. It's a little cooler up here. Now, what is right here? It's the sky, right? It's so small. It's a section of the sky. Now, is the sky visible? Yes. Because I'm seeing the light. Actually, we'll talk about the diffraction later, but I'm seeing the light that's coming through the atmosphere. Now, some of those light waves go here. Now, as the light goes from the cooler air to hotter air, it's going to speed up, which is going to cause it to do what? Listen. As it speeds up, it's going to refract. Which way? If I'm going this way, is it going to go right or left? Which wheel hits first? Left or right? Left wheel hits first. Does it speed up or slow down? Speeds up, so it's going to bend to the right. If my left wheel goes faster than my right wheel, it causes me to go to the right. So that light ray bends.
Yeah.
And hits me in the eye. Yes, to be worse than others. But my brain is taking shortcuts. And so my brain thinks that that light ray did what?
Came on the ground.
Oh!
No, it's like wavy. Deep wavy.
My brain thinks that that light ray traveled straight.
The brain takes the light, the size on the ground,
Yeah, no. What does my brain say when my brain says blue on the ground? What does it think? Water. What am I talking about here? This is a mirage. You got to take your pants off.
I did.
Right. Mirage. Right? The light from the sky is bending, it's refracting as it gets to the hotter air above the pavement and bends up towards my eye. My eye then says, hey, it came straight from there, and when my brain sees blue on the ground, it says sky's not on the ground, water's on the ground. And so my brain says water on the pavement. As I get closer, that angle, right, as I get closer, that angle's too low, it doesn't hit me in the eye, and so I don't see it anymore. That's why it keeps disappearing and appearing farther away.
That's crazy.
All right, see you next time.